This video is entitled Keys and goes along with Chapter 4 of the Introduction to Database Systems Modeling and Administration book. My name is Dr. Reneau, and I'll be taking you through this video presentation on keys. So what is a key? Well, a key is an attribute or a group of attributes when taken together that uniquely identifies an instance of an entity. So think of, we have an entity, the data model entity that represents a customer, but you might be a customer, I might be a customer, somebody else over there might be another customer, and each of us would be different instances, different creations, different people, different entities, or different instances within that single entity. You can also think about, we have an entity called parts, but each individual part is a separate instance of that entity. So we need a key or multiple keys to be able to go grab that entity, that instance of an entity from the entity table itself. So that's what a key is. Keys are used to create fast lookups, retrieve a specific instance of an entity or row, or to create special relationships between entities. And we'll see that in the next chapter's video. To be a good key, to uniquely identify a single instance of an entity, a key must be unique, non-volatile, minimal, not null, and secure. And I'm going to go through each of those 5 properties individually. So, a key must be unique. It must identify a single row. And a key could be, again, as I said in the introductory slide, a key can be made up of a single attribute or multiple attributes, and we'll talk about that later. But examples of a good key, for instance, maybe you've got an entity that contains order information. Well, order number would be a great key. Serial number for an item we produce, that would be unique, right? We only give that serial number to one of those, or other frequently assigned identifiers like a UUID or a sequential numbers. Think about you as a student. Maybe if you're a student, you're in your school's database of the student entity. You're an instance of the student. You're another student that we track. Do you have a student ID number? I bet you do. And that would be your unique identifier, or that would be one of your unique identifiers. Can we use last name as a key? No, because we could have multiple people with the same last name and we would extract multiple rows at once. If we put last name and first name together, is that unique? No. You probably know somebody, or you probably know 2 people with the same first and last name. Um, there are a lot of John Smiths out there, or Jack Joneses out there. So that's not unique. Well, we can add a middle initial. Was that going to be unique? Not if we have, maybe if we have only just a few dozen customers, but if we have thousands and thousands and hundreds of thousands of people or hundreds of thousands of entities, then nope, that's not going to work either. So a key should be, well, we'll talk about that in just a second. The next thing a key really needs to be is non-volatile. And when I say non-volatile, I mean that the key shouldn't change. Um, for instance, let's think about people. Let's think about our customers again and our customer entity. Using their telephone number as the key might be okay, but it might not be a great, because sometimes people change their phone numbers. Would, again, last name and first name concatenated together be a good key? No, because, well, it's not unique. But people change their names. Maybe they get married, divorced. Maybe they just decide to change their name for some reason. Um, Email addresses. They might meet the unique test because each email address is unique and two people don't use the same email usually. But could email addresses change? The answer, well, yeah, they can change sometimes. Maybe somebody left employment and or creates their new business and has a new domain or whatever. Lots of reasons these things can change. So these are attributes that are volatile and we don't want to use those as keys. Now, can we use them as indexes and use them to look people up? Well, of course we can. When you are asked by a customer service rep what your phone number is, they'll look up your phone number and they may get multiple people with the same or similar numbers and then they know your name and go, oh, well, that would be you because the name and phone number combination, even if they are volatile, is still good enough to find you in a customer service environment or some other environment like that. So don't just think that we can't use these non-unique values to look people up or look things up. We just can't use them as keys. This is where keys are minimal. And this is where, we could jam someone's last name, first name, middle initial, and birthday all together. And would that be unique? Yeah. Would it be volatile? Well, yeah, so that's not a good one. Um, but we could just jam enough stuff together, enough attributes together, and say, yeah, that's unique. That's great. Let's use that as our key. Well, that becomes problematic because keys are duplicated throughout our system as we're building a data model. Um, Keys, we'll see all kinds of things that we use keys for. So, keys really should be as minimal as possible. So, and that's especially true when we start jamming multiple attributes together to create a composite key. So if we're creating a composite key, the least number of attributes possible together, or if we don't have a good simple key, then it might be time to create a synthetic attribute that contains a key. And we'll talk about that. Keys can't be null. We can't have an unknown key because, well, there could only be one unknown key. If the key is unique, we can't say, well, unknown let's get the unknown key and then that would be the one person that's unknown. But so we just don't want null values or the unknown value to be in a key. And we don't want it to be one of the attributes if we're putting multiple attributes together to create a key for an item or a key for an entity. It's really strange, the mathematics with null. When we get into the mathematics of null later, we're going to see that null plus anything else is now null. So emptiness plus something is emptiness. So yeah, we just can't use null or null values or a null attribute in a key, no matter how hard you kind of want to. Because we really worry about data confidentiality and security, a key should be secure. And when I mean a key is secure, it doesn't include any confidential or private information. So, social security number, passport number, driver's license number, or other personally identifiable information shouldn't be included or shouldn't be used as a key. While they might meet the previous constraints of unique, not null, um, uh, unique, not null, and simple, it's still not a good idea to use these kind of um, special things as a key. For instance, using a birthday as a key. That's probably not something you want to expose to everything, to the entire system. Using a social security number, again, passport number, those kinds of things. So you need to not use private or confidential attributes as a key. Now, I've alluded to this in my previous slides. A key can be a single attribute, a simple key, or a key can be a composite key of multiple attributes kind of jammed together. Let's talk about a single key. A single key would be just a single attribute that makes a good key, meets all the criteria we've talked about before. Examples: an identifying abbreviation. For instance, maybe we're a wholesaler of some kind of part, some kind of item, and each item in our inventory we're going to assign it a 5 letter, a 3 to 5 letter code that's an abbreviation of its name, something of that sort, that we all just kind of know these codes for our most common items. That'd be a great attribute to add, a synthetic attribute that we would add that would be a great key. A UPC code, the barcode on something you're for instance, here's a can of soda, and there's that barcode. Would that be a would that be a great would that be a great key? It's a great key, um, because it uniquely identifies that item. A customer number or student number or member number or member code or something like that would also be a single simple key. Assigning a UUID or a random number or a sequential number, again, would also be a great simple key attribute to use as a simple key. Composite key. Composite key is made by concatenating multiple attributes together. Um, and while you can do it, most lots of the times it doesn't. I mean, it's not the best thing to do, but you can do it. But here's an example that I have seen in data models and I have seen used. For instance, maybe we have an item entity that contains all of the items that we sell as a business. The composite key would be the vendor code with the vendor item number. So we get this item from ABC Supply and it's number one. So it would be ABC1, where we get this item from XYZ Company and it's also number one, but it's a different item. It's a different product because XYZ calls it one, ABC calls it one, but they're two different things because we're buying them from two different vendors. So we could concatenate the vendor code and the item code together, at which point then it works as a composite key because vendor code and item code, even if two vendors assign the same code, still uniquely identifies that item in our entity. There's also something called a compound key, which is a special kind of composite key made up of foreign keys, but we've not talked about a foreign key yet, and we'll deal with that later because we're just talking about keys in general at this point. Here's an example where a composite key might be a really good key to use. For instance, we have an entity that contains the quantity on hand that we have in our multiple stores. So imagine you've got a company with multiple locations and we've got items in each of the stores that we're selling. So in store 12, you can see that we have item 345 and we have 4 on hand. We can also look down and see that in store number 34, we have 345s and we've got 3 of them. But in store 56, we don't have any of them. So this table, this entity has three attributes: store number, item number, and quantity on hand. And what would be the unique identifier? Is store number unique? No, because you can see the store number repeats multiple times. Is item number unique? No, you see the item number appears multiple times. Is quantity on hand unique? Well, it's not, but we don't want to use that because it's very volatile. Every time we get a new item in or sell an item, that would be changing all the time. So that'd drive you nuts trying to use that as a primary key or use that as a key in general. So here in this example, I'd like to see us concatenate the store number and item number together to create a concatenated or composite key. So a candidate key. Um, an 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 entity can have multiple keys. As we've gone through and looked at our data, we've sorted through it, we understand all of our attributes, and there's if we concatenate these three things together, that's a good key. We could use this single attribute, and that's a good key. There could be multiple keys, and we call all of those possible keys a candidate key. Um, and we'll want to remember all of those because we're going to use them later for searching and indexing and retrieval, because it might help someone go find an item or find an attribute, find an instance of an entity. So some are singles, some are concatenated, and some are surrogate, which is a key that we've made up. We've just kind of assigned a number, like a student ID number or a customer number or something of that sort. So those are so there could be multiple keys, and we call all of the all of the valid keys that could work candidate keys. From the list of candidate keys, we're going to choose one key, one attribute or combination of attributes to be the primary key. It uniquely identifies this instance of an entity, and we're going to use that in other entities to connect our entities together to make our data relational and to really model real world situations. Again, it's usually the simplest of the candidate keys, and sometimes it's a synthetic attribute called a uh, my brain just froze for a second. A synthetic attribute called a surrogate key. This is more just a definition I'd like you to know, that a natural key is a key that just occurs naturally. It's something that an entity usually knows about itself. For instance, a social security number would be a natural key, or a passport number or a driver's license number might be a natural key. It's not a good one, though. It's not one we want to use as a candidate key, but it is something that we may want to use, or may want to at least remember as we're modeling our data. Surrogate key. Now, I mentioned it in a previous slide, but I didn't define it, and I probably should have flipped the slides around. But a surrogate key is added when we don't really have a good candidate key, or maybe we've got a complex concatenated key that's just kludgy and just a little bit more difficult than we want to deal with. And so what we will do is we will just create a new attribute and say we're going to assign everybody a key. Usually it's a sequential number or a random number like a UUID, a universally unique identifier, or something of that sort. And we've all been assigned customer numbers, student numbers, item numbers, um, ISBN book numbers, barcode numbers. Those are all surrogate keys that aren't natural attributes of an entity. So as we move into the logical data model, we need to mark the attributes that are our key, our primary key. Usually the way I like to diagram, and there are several different ways to draw these entity shapes in different books and different models, slightly different models and different software, but this is the way I like to do it, and it's common, and if you understand this you'll be able to pick up on other people's specific diagramming quirks. But I like the key to be in bold up at the top. The first attribute or attributes will be the key attributes, and there'll be usually a space between them, and I make them bold so they stand out, so we know that that is the key to the entity. Some data modelers put a little uh, set of parentheses in the letter PK either after or a little PK prior to it, defining that that is the primary key attribute. But I'm going to do it modeled like this with it in bold. Here is an example of another entity, and this would be a company. Maybe we have an accounting system that we're working on that's going to track data for multiple subsidiary companies. Um, you can look at the data that we have company ID description and their taxpayer identifier or their uh, whatever their taxation ID number, because most of us have one of those, or most companies do. Um, Tax ID number would be unique. It would be non-null because a business has to have one to be a business. So could we have used that as our primary key? Could we have used that as a key? Yeah, it's certainly a candidate key. Is the description unique? Are we going to have two companies with the same name? No. So those are unique. Oh, so the description could be a candidate key, the tax ID number could be a candidate key, the two concatenated together, jammed together could be a candidate key. Oh, so I've too many candidate keys, but they're all big. You know, taxpayer ID number would be a big long number, and could you remember all of them for all of your companies? Maybe not. So in this case, we've created a surrogate key. We've created a synthetic key called a synthetic attribute called company ID, where we're going to just assign each company a number. Company number one, company number two, company number 99. And that we will use as our primary key, reserving the other candidate keys for us to look things up. And our last example will be the example of maybe you've got a general ledger system where you've got companies, multiple companies, you've got multiple ledger accounts for each company, and then you've got a balance of each of the ledger accounts. And you can see that company ID is not unique. Account ID probably is not unique because most of the companies would have an account 1000, and the balance would be a very volatile attribute, so we don't want to use that. So we could create a surrogate key, row number or balance number or something of that sort. But in this case, I think by concatenating the account ID and the company ID together into a composite key, I think that would work really well for us. And you can see how that is described in the entity shape as we move into our logical data model. This concludes our video on Chapter 5, Keys. Thank you for watching. And if you like this, if this was helpful, we'd love if you'd hit the like button or subscribe or Yeah, just send us a message saying how much you loved it. If you find an error, please let me know. I appreciate it all, and have a great day.